Good morning, good afternoon, or good evening. Thanks for joining this Antrea community meeting. Today is Tuesday, September the 27th, or for some of you on the West Coast, is still Monday, the 26th of September. For today, we have a very packed agenda, so it's going to be a very interesting meeting. We will start with a demo of the stretch network policy feature for multi-cluster, which will be presented by Young and Grayson. This is expected to take 15 to 20 minutes according to the number of questions that we get. After that, Rahul and I don't know who else will present a new project for security policies on public clouds with Antrea, and I hope that I get the pronunciation correct. It's Nefi. And I mean, if I got it right, then Rahul will correct me. So I believe that we can get started with today's meeting. So thanks again, everyone, for joining. We have a very good attendance for today. And for the stretch network policy demo, I don't know who's going to go ahead, Young or Grayson?
Yeah, I'll start talking first, but I don't know if Grayson
has the permission.
Cool, sounds good.
Can you guys see the screen?
Yeah, I think so.
Yes.
All right. So thanks, guys. This is Yang, and Grayson and I will be presenting, the latest status of the stretch Antrea native policy. This is the same slides that we've presented a couple community meetings ago, but since we have some updates, I just wanted to quickly go through the slides again to show you guys what the updates are to the Antrea native policy, and then Grayson will show you a nice demo of the stretch network policy in action. So a bit of a background, what we're trying to do here is that currently we have a multi-cluster feature for Antrea where we sort of like unite a couple of clusters together in what's called a cluster set. And, regular Kubernetes services in one of the cluster can actually be exported to another cluster so that in that other cluster, pods can just use the services cluster IP for accessing the service endpoints, which are actually on another cluster. So right now, before stretch network policy, with the Antrea native policy, we already have a way to secure the egress direction of the flow, which is using the two services feature of ACMP. Basically, we can apply a policy to pods and select what are the services that the pod are able to talk to. These services can be in-cluster services, but they can also be exported services, or imported service from another cluster. The limitation to that is that before the stretch network policy, we don't actually have a way to enforce ingress direction traffic for an exported service, meaning that if I have a couple pod which is under a service that's exported to another cluster, I can't really control who in my cluster or the other clusters in a cluster set can access the service that I'm exposing. So this is what the stretch network policy brings up to the table. How we realize the stretch network policy is through a thing that's called label identity. Basically, for all the pods that are in a cluster set, we sort of like we use a label identity to categorize them. If a couple of pods share the exact same labels, which basically means that they belong to a deployment or whatnot, they will have the same label identity, which is categorized as a unique string calculated based on their pod and namespace labels. And what we do in a multi-cluster service is that we do a replication for this label identity. For all the label identity that exists in the cluster, we send a resource export first to export it into the leader cluster. And then the leader cluster will also distribute these label identities to all the member clusters, so that all the member clusters in the cluster set will know how many label identities exist in the cluster. And also, we assign a ID for each unique label identity, which is also synced across all the cluster in the cluster set. So by the end of the day, Grayson, can you move to the next slide? Thank you. So by the end of the day, what will happen is that for each of the member cluster in the entire multi-cluster cluster set, we will have a label identity. We will have a list of label identities, which is basically a normalized label and the ID assigned to the label. So every cluster will have the same information. This is sort of like the basis on how we were able to enforce a stretched network policy. And moving on to, okay, so this is just basically, what we added to the already existing resource export struct. So we're using the same sort of like resource import and export pipeline that is already used in a multi-cluster to realize this functionality. The same pipeline is used also for service exporting and service importing. So this is sort of like just a example on what label identity actually looks like. So sorry, can you go back? Yeah, just really quick. So if we in the namespace A, we have two pods. One pod has label app equals client, and the other also has label app equals client in the namespace A. Then those two pods will basically share a label identity because they are in the same namespace and they belong to the same deployment. And so they have essentially the exact same labels, not only for the pod, but also for their namespaces. On the other hand, in namespace B, we have a pod A and pod B, which has different set of labels. For those two pods, we will have two different label identities because pod B has an extra set of labels. So in total, in such a cluster, we will have 3 label identity exported, and every member cluster will learn this normalized label to ID mapping. Yeah, I'll skip this because it's just sort of like bookkeeping on how it's implemented. I'll just pause really quick here to see if there are any questions so far. Okay, sounds good. So moving on to the data path side of the label identity. For the stretched network policy, we actually will use the VNI bits in a pod classifier flow in OVS to implement the stretched network policy. What we mean by that is that for any traffic that's sent from one pod, possibly in one of the clusters, to another pod that's a backend of a service, and that pod might be in the same cluster, it might be on a different cluster, depending on if the service is exported or not. So how we realized a stretched network policy is that on the sending pod, if a traffic is sent from a pod to another pod, on the sending pod's node, we always add a classification flow, which basically loads the sending pod's label identity into the VNI bits in the OVS. If you can see, the green highlighted green bits, it says set tunnel. So this basically sets the VNI ID in the OVS for this specific traffic, and the value set is basically the label identity ID assigned. And on the receiving pod node, if there are any stretched network policy applied to this pod, then we will have a bunch of rules basically matching the source by the tunnel ID. So if we have a rule saying that I wanted to allow a drop from a specific set of label IDs, we'll just put these, we'll just put a matching condition for these tunnel IDs and then enforce the policy that way.
Yang?
Yep.
Where will the pod identity be computed and the VNI set? Will it be at the gateway node?
Not really. So if you Grayson, can you go next slide to the sorry, can we go back to the export and import slide? The diagram one.
This one.
Yes. So essentially, in each member cluster, we will create a resource export for every new label, every unique label that the cluster has. Now, in the leader cluster, since every member cluster is exporting these, the leader cluster will do a deduplication and also do the ID assignments for each unique label. And this information will get back to the member through a resource import. So
I was asking where the value gets injected into the packet.
So that's on each node of the pod, because on each node there is an Antrea controller running who already knows the label identity mapping. So as soon as the controller gets this sort of mapping, the controller will basically inject that ID for each pod in the classifier flow, if that makes sense.
Anthony, do you mean this classifier flow is on either regular node or gateway node, or who is maintaining this flow?
No, I think Yang answered my question. I think it's clear to me. Because in my mind, I thought at some point in the future it would be possible to use multi-cluster with each cluster, with specific clusters running in no encap mode, but I think that's never gonna be an option, that you can only use multi-cluster if each cluster is using encap mode. I guess ultimately that's what I was asking. And if like the node on which the sending pod is running is the one that needs to inject the pod identity as the VNI field in the packet, then I guess it's kind of like a requirement to have each member cluster run in encap mode, because otherwise there is no VNI field.
Yeah, this is sort of like a implicit requirement that we have right now, because for no encap we haven't really thought through on how a stretch network policy can actually be enforced yet.
Dick, Yang, and Antony, actually, I think we talked about for low encap and for policy only. Even we don't encap traffic between nodes, but we still encap traffic across clusters. That means for cross-cluster traffic, we can still have this VNI field.
No, I agree. That's kind of what I was asking. But if the packet has to go from the sender node to the gateway node, which is going to do the encapsulation, right? And at that point, you will encap the packet and you will be able to set the VNI. But that means that the VNI is set at the gateway node and not at the sending node.
No, even between the sending node and gateway, we encap we tunnel the packets.
Oh, okay. All right.
Otherwise, you don't have a way to forward the traffic. Yeah, I believe so. Otherwise, how we send the traffic to the gateway node?
Hi, Yang.
Yeah.
On the gateway node, do we need another flow to load tunnel from the receiving port to the sending port. Will this tunnel be resolved when gateway node forwards it?
I think I can answer this question. We don't have to change any flow in the gateway node. This is will go with this packet until it's reached the very end.
Okay, thanks.
Yeah.
Yeah. Okay. I'll just move on a bit if there's no other questions.
Sounds good to me.
Cool. So yeah, this diagram basically captures, what's essentially going on for loading the ID in the classifier table from the sending node, and then the traffic go through the gateway node to another cluster if the traffic is intended for service backend on another cluster. Then on the receiving end, we also have an Antrea ingress rule table, which enforces rules based on label identity ID if there are any Antrea ACMPs or AMPs applied to these pods. So the CRD type, actually, the stretched Antrea network policy is still the ACMP or AMP that has been in Antrea like in forever. But we added a new field called scope equals cluster set as a special flag in the ingress rules for the Antrea native policies. So when when the CRD is set as scope equals cluster set, it means that for the pod selectors or namespace selectors or a combination of selectors specified below, it will be applied to the scope of the entire cluster set rather than the cluster itself. So it will basically have the the similar workflow as the Antrea native policy that people are already aware. It's just that we can use this special flag to select the entire cluster set. We can move on to the next slide. Right, so this is just a quick example on if we have an ingress rule that selects a bunch of things from the cluster set scope. And we also have label identities that are basically selected by these selectors from the ACMP rules. Then when we convert the ACMP into a control plane network policy internally after the Antrea controller process this policy, the rule becomes a bunch of label identities, which is 1, 2, 3, and we sort of distribute this rule to each of the agent that this policy applied to. And on the data path side, the agent will program these label identity IDs into the data path so that any incoming traffic that matches these label identities will be allowed or dropped or or rejected based on the disposition of the rule itself. And this is just a reference on what the flows will look like for what the rules will look like on the data path if the agent received a control plane rule looking like the left. I won't go into detail for that because we are already a little bit out of time. So I'll just jump to leave the floor to Grayson to show you guys a really quick demo on the stretched network policy capabilities right now.
Okay, thanks, Yang. So I'm gonna show you guys a short demo video to give you a rough idea about how stretched network policy works. As you can see on my screen, there are two terminals. The upper terminal is in the cluster where I run the client pods. As you can see, there are two client pod, client 1 and client 2. They have the same labels, which is app equals test client. And in the lower terminal, it's in the cluster where I run the server pod and start the service. Also, on this server cluster, it already exported the service to the whole cluster set. So on the upper cluster or the client cluster, we already can see the Antrea MC Nginx service imported to this cluster. So both the client pod can access this service normally if there's no network policy applied on the server pod. So client 1 can access it, and client 2 also can access it. And then in the server cluster, we're gonna apply a cluster network policy. As you can see, the scope is the cluster set at the very last line, and it will select the app equals test the client. So both client pods will be selected by this strict network policy. After we apply the policy, then both client traffic will be dropped in. Now let's see if we update one of the pod label to test app, for example, and we apply it. Then the client 1 should able to connect it to the service, but the client 2 traffic still be dropped in. Now let's see if we update the network policy to match the test app. Then the situation will be reversed. The client 2 can connect it to the service, but the client 1 traffic will be dropped in. Yeah, that's pretty much a simple demo video.
This demo video is basically just to show that we can handle pod label update events, and we can also correctly handle a ACMP policy update for different labels. And even though this looks quite simple, a lot of things are sort of like happening under the hood. For example, if a client pod changes label, what will happen is that in the entire cluster set, we'll have a label identity delete and also a label identity add, because the pod is changed to an entirely different label identity. So this will go through the leader cluster and the member cluster, and then finally the member cluster will sort of like receive these events. And when the member cluster receive these events, it will also trigger any ACMP that affects this label, and the ACMP will sort of like be reprocessed to take these changes into account, and the data path flows will then be rewritten to capture these changes. And that's how the entire stretch network policy is realized on the enter and on a cluster set level. And that's basically it.
Yeah, both the flow in the classifier flow and a classifier table and the Antrea ingress rule table will be updated according to the label identity update event.
Yeah. Thanks, Grayson. We're ready for any other questions regarding demo, if any.
Cool. That was a nice introduction, a nice explanation of the feature. I have to say that often the demos, when there are these kind of features that are really hidden in the, let's say, in the control plane and data plane, the demo seem a little bit disappointing. Like you do a lot of work and then the demo is like 30 seconds. Yeah, it's done. But anyway, that was great. Thanks for this great explanation. And do we have Any question or comment for Yang and Grayson regarding this feature? Cool. So the PRs for this feature are in review, and this is something that will most likely be part of the Antrea 1.9 release. So at this stage, since it appears that there are no more questions, I would like to thank a lot Yang and Grayson for this presentation, and we can move to the next topic. So,
Claude, I have one question.
Yeah, go ahead, Sean. Sorry, go ahead.
Have you ever tested how long typically it will take for this stretch narrow policy to take effect? It's about a few seconds or less than 1 second?
Yeah, that's a really great question. This is a part, because of the time limitation, we haven't been able to expand on. I don't have an exact answer to that, but I think Grayson would know. But the thing is, if we have a delay in sort of like label identity ID communication from the leader and the member, which means that the member wasn't able to sort of like receive an ID assigned for a new label in really quickly. We also do something called a security flow, which is also suggested by, I remember it's could be suggested by you, means that if we have a pod that whose label identity we don't know what the ID is, we will first put an unknown ID for that, and essentially for any policy selecting pods, which is a backend of a multi-cluster service, when they encounter an incoming traffic carrying an unknown ID, on security purposes, we just default it to drop. We just wait until the ID actually comes, then we update the flow into a real network policy flow. But I don't know if Grayson knows what we usually observe in terms of the time delta for this change to happen. I expect it to be really slow, really small. But I would also acknowledge that it also depends on a lot of other factors, such as scale and other network conditions between member and leader.
Yeah, so I think the bottleneck for this is just the exchange between member cluster and the leader cluster, the label identity assign. I have done a test in our multi-cluster testbed. I update the namespace, which has 100 pods inside it, which would basically trigger 100 label update, label identity update. I'd like to say it takes roughly, I didn't count on the clock, probably 4 or 5 seconds.
4 or 5 seconds for updating one namespace case, you mean?
Yes, which has it's 200 pods, yeah.
Oh, okay, for all of them to take effect.
Yes.
I see. Thank you. Maybe we could also test when we create a new pod or updating a network policy selector, pod selector in the network policy, how long it could take typically. I think that's a more common scenario. Updating namespace label, I think it's not a very frequent operation.
Yeah, if you update the selector in the network policy, this could be very fast, since the network policy won't do anything with the label identity create or delete. It's just check if if I know this label identity in my cache. If I know it, I will just put the label ID in the cache, implemented in the data path. And the pod created event, I use the namespace because I want to trigger 100 or 200 label identity update events at the same time. So I think pod probably is just 4 or 5 seconds divided 200s.
Yeah, and I think for the sake of time, I also wanted to say that, you know, I think this is tested before we change the label identity controller to, you know, sort of like an async queue processing, as you just suggested not long ago. So with that, we probably will get some performance improvements because we can sort of like concurrently process more without, you know, complicated locking mechanisms. So we'll probably, you know, test it more and, you know, get back to you with the latest results.
Thank you.
Yes. My test is like done almost like 3 weeks ago or a month ago. I will try to do more legit performance test with the latest changes. Yeah.
Great. Thank you, Grace, and yeah, thank you.
Okay, thanks. And as we said, in the interest of time now, we have to switch to a new topic because we need to grant enough time for Raul and their team to present this new project. We're running a little bit late on schedule, so likely this meeting will last a little bit more than the scheduled hour. So hope that that's okay for you, and I will stop talking in the interest of time and let Raul do this presentation.
Hi guys, thanks everyone for joining the call. You guys can see my screen, right?
Yes.
Okay, yeah. Perfect. All right. Thanks everyone for joining the call. Today I'm going to talk about Project Nephi. I'll provide a brief introduction of what Project Nephi does, what are its capabilities, and follow up with a brief demo or a short demo. First of all, how did we come up with this name? So we were looking for something which has some relevance to cloud because this project is targeted for cloud and cloud resources. So we chose this name, and this name is actually derived from Nephele, which actually means goddess of cloud. But when we looked at this name Nephele, there were a lot of open source projects with this name. So what we did is we just shortened this name and we call it Nephi. So the pronunciation is Nephi. Very good. Introduction. So what is this? So Nephi is targeted for public cloud resources. And essentially what we do here is we take Antrea network policy and we translate and enforces those policies on public cloud resources. Now, what I mean by public cloud resource is in the first release, we are targeting virtual machine, but the design is such that we can extend the support for other public cloud resources like native services, load balancers, and so on. How do we do the policy enforcement? So we use cloud constructs, which is what we call network security group. So think of network security group contains all the rules. It contains the rules, and then you apply this network security group to the public cloud resource like virtual machines. Typically for a VM, it's applied on a network interface. So you would be hearing this name network security group or NSG frequently. So as this project translates Antrea network policy, right? So the choice of network policy CNI must be Antrea. And I'm explicitly calling it out as network policy CLI because if you take some managed cloud, so they do have options of choosing network plugins separately and a policy plugin separately. So for Nephi, we need the network policy to be Antrea. For Nephi, we only support whitelisted policies. What I mean by whitelisted is for an ANP, we will only support allow action. The reason being like one of the cloud AWS doesn't have an action like deny or drop or something like that. So what we do is if we see any Antrea network policy which has drop action or deny action, we throw an error and we fail the realization. We wanted to unify as many cloud as possible. So we went ahead with the whitelisted policies only.
Rahul, what do you think there will be use case for delay rules for Azure and Google Cloud?
Yes, Azure do support drop and deny action, so basically deny action. But then we didn't want to unify. We wanted to unify all the clouds, and I think for I have to check, but GCP does support. I think it does support deny action.
Should be.
So based on feedback, we'll figure it out that we want a specific cloud specific handling of entry network policies, or we wanted to keep it generic. Right now, we kept it generic.
Okay, I'm just thinking aloud here, because if you don't have deny rules, I think some of these Antrea-led policy features are useless, like policy priority or rule priority. I'm not sure if we can optimize a little or not, but maybe one thing to consider.
Okay, we can take that into consideration, Janjan. Okay. I'll evaluate GCP also just to see if GCP supports it, and I'll also sync up with you offline that if those features which you just brought up, we just mentioned, we would those are critical or not, or we need it in our next release.
Sure.
Okay. Right now, we support both AWS and Azure Cloud. And the architecture is such that it's a pluggable model wherein other public clouds can be easily inserted in NEFI project. As part of this new project, we introduce a few CRDs. First CRD is Cloud Provider Account CRD. So using this CRD or CR, the user would be able to onboard a cloud account in NEFI. So this will essentially carry credentials like AWS credentials or Azure credentials, what region you want, your resources to be onboarded in Kubernetes. For example, let's say some user may not want resources from a region X or region Y, right? So they want some resources of region X to be onboarded, but not from region Y. So they will use this CR to create a resource and then specify which region it wants the resources to be imported in. And I'll cover this further in the next slide. Then once an account is added, right? So in a single account, you would have a lot of resources like virtual machines, VPCs, and so on. Right? There are many resources. So what resources you want to onboard on Kubernetes or NEFI? So this Cloud Entity Selector CRD is going to provide a user an option to onboard a public cloud resource of a particular cloud account. So this is the use of it. So first CR would carry credentials, and then the second CR will actually be used to specify what resources you want to be imported into Kubernetes. The third CRD is the virtual machine CRD. So once we have figured out that these are the virtual machine CRDs matching CES criteria, so we onboard those virtual machines as CR, virtual machine CRs in the Kubernetes. Okay, I saw a response from Banky that GCP doesn't support deny, so only Azure supports deny. That's good. All right, sample CPA. So in this, how we are adding a secret in FAs. Earlier, we were adding the access key and secret key inside the CPA object. But due to security concerns, what we did is we separated this out into two, wherein user would first create a secret. And in the secret, will have an opaque object which will have credentials. And in the credentials, we take the base 64 encoding of AWS key and secret. And we expect the user to create this secret in NEFI namespace so that the NEFI controller can read this secret, which is added by the user. And in the CPA object, like I was mentioning that it'll have AWS and Azure config. And in this CPA object, you can specify which region you want your resources to be imported from. And it'll carry secret reference. The secret reference is basically name, namespace, and key. So this key is essentially basic C4 code encoding of AWS key, AWS secret, and IAM roles, and similarly for Azure. So that's the use of it, that using CPA CR, you are able to add AWS account or Azure account into Nephi. So once you have added a CPA object, the next thing is you add a CES object. So CES object is where you specify that out of a lot of resources of a particular account, which resources you want to be imported into the cluster. So the CS object will carry name, namespace. It will have a reference of which cloud account this CES is part of. And right now, we are only supporting virtual machine CR. So we have this VM selector, but in future, if we have other selectors, this thing will grow. So in this sample example, I'm using a VM selector, and in the VM selector, VM selector supports 4 different combinations like VPC ID, VPC name, VM ID, and VM name. So in this sample example, I'm using VPC match with the match ID as this ID. So what it means is any virtual machine part of a VPC, this VPC would be automatically onboarded into the Kubernetes cluster. So that's the use of the second CRD. A high-level workflow of how things work in Nephi. The boxes which you see in blue are user input, and then these are the operations we do in cloud. So I'm going to talk about each of this one by one. So first, the user would add a CPA object which carries credentials and secrets. Once the CPA object is done, you specify which resources you want to be imported. So using CES CR, you add that matching criteria. Once these 2 things are added, what Nephi does is it polls public cloud and identifies all the resources matching the criteria. And once it has identified that these are the VMs matching the criteria, it creates a virtual machine CR for it. So virtual machine CR, right now we kept it for visibility purpose, like it carries the running state of the VM, if it is up or down, the VPC the VM belongs to, and I'll show this in the demo. So it's mostly for the visibility purpose. Then once we add the virtual machine CR, today Antrea network policy is actually applied on external entity. It doesn't understand virtual machine CR. So what we do is we also add a one-to-one mapping between the virtual machine CR and external entity. So what Nephi does is whenever a virtual machine object is added or deleted, it adds an external entity or deletes an external entity accordingly. And then what we expect from the user is, instead of using the virtual machine, they use this external entity and apply the Antrea network policy on the external entity. And once this Antrea network policy is applied on the external entity, which is created by Nephi, the Antrea controller sends this internal Antrea network policy to the Nephi controller, and then the Nephi controller applies this Antrea network policy on the public cloud virtual machine via a network security group like NSG. So this is the overall flow. And then, so this network, just to reiterate, the network policies, they would have to apply on the external entity, which is added by Nephi controller. And then the way Antrea controllers disperses the policy is it looks at the external node field in the external entity and decides that, okay, this external node inside external entity is has a NEFI controller in it as a field. So, and then if it sees any Antrea network policies, which is referencing a external entity which is created by NEFI, then only those policies are received by an NEFI controller. And it will be clear when I show this in the demo. I'll take a pause here because this is essentially what we do in NEFI. And so any questions on this workflow?
There is I don't know if it's a question or a comment on the chat, and Banshee is telling us that GCP does support deny network policies. I don't have the context for this, so I don't know in which context this is.
Yeah, so Jenjun actually mentioned that. So I mentioned that we only support whitelist policies because AWS doesn't support deny action. And looks like Benki quickly checked GCP cloud, and GCP does support deny action. So both Azure cloud and GCP cloud does support deny action. Yeah. So and as Zenjun was mentioning that there might be some features which might be meaningless if we don't support deny action. So we will have an offline discussion with Zenjun to figure out what those features are, and I'll take it from there.
Thank you.
Just a quick question. So you just mentioned that this is only sent to the NEFI controller if the policies are actually applied onto the external entity. So does that mean that if a policy applies to pods in the cluster, and for ingress and egress it selects external entity, this will still be enforced by Antrea controller, and the addresses are just computed as the external entity's addresses? Is that correct, or that case will also be handled by NEFI controller?
So let's take a step back here. So the NEFI controller applies the network policies on the virtual machines on cloud, right? So which is this. Now, what is its representation in Antrea controller? Its representation is external entity. Now when you apply a network policy, and if you let me just see if I have not. Okay, so I thought I had a reference external entity, but in the external entity, we have introduced this field called external node, which is essentially means the owner, right? So now if a network policy is meant for an external entity which has an owner field as NEFI, then only the Antrea controller will send those internal policies to NEFI controller.
Okay, yeah, thank you.
Otherwise, even if, let's say if I receive a pod policy, or even if I receive some XYZ policy, NEFI cannot do anything with it because it will first take the external entity from this internal address group and apply to group, and would identify what is the virtual machine belonging to that particular external entity, and then only on that particular VM it applies the policy in cloud. So it needs external entity. So if I go to the next slide, the apply to field here, which is this guy, the apply to field should always be external entity selector. And then the external entity selector, you can use any label on the external entity. So when we create an external entity, we add a few fixed labels like kind NEFI, tag NEFI, and so on. And we also discover tags from the public cloud and add those tags on the external entity. So the user can easily use those labels when defining an Antrea network policy. And then if it wants those VMs to be managed using Antrea network policy, then they have to use this entity selector, external entity selector, and then include that in the apply to field. I hope it answers your questions.
Yeah, that answers question. My question was basically about, if let's say in apply to it's not external entity selector, but in the ingress and egress it has external entity selector, that case will still be handled by Antrea controller.
Yes, that case, yes. The Antrea controller is smart enough to figure out to which backend it has to send it to. Typically, the other consumer would be the agent, Antrea agent.
Yeah. That's that's basically my question. I just wanted to make sure that the policy is not enforced twice on the Antrea controller and the NFV. Yeah, but yeah,
Sure.
That answers my question perfectly. Thank you.
Thanks. All right. Again, any questions on this workflow before I move on, because this is the crest of NFV.
Well, let's do the same. 5, 4, 3,
Okay.
2. Okay, it seems there are no more questions. Raul, you can go ahead.
Perfect. So other thing which we have done is we have used Kubernetes dependent concept, wherein we have added dependencies on the objects. So the CPA object, the CES object will have an owner reference as a CPA object. Virtual machine will have an owner reference as a CES object, and so on. So in that way, whenever if somebody removes, or if the user removes the CPA object, the Kubernetes will make sure that all its child objects would be removed automatically. So this is, we use Kubernetes construct to achieve this. Like we added a dependencies on each objects. Sample Antrea network policies. Again, we only support namespaced policy, namespaced, not a cluster scope, a namespace scope. It has to be applied on external entity only. Like if you apply it on a pod or some other resources, the NFV controller will not even receive the policies. And then the ingress, in the ingress, you can either have like an IP block or external entity selector. So this is fine. I mean, like you can even have an IP set. So we don't have an issue here. We just have to make sure that the policies are actually applied on the external entities created by NFV control. So how is the Antrea network policy enforcement done? So as you guys are aware that the Antrea network policy is converted into internal Antrea network policies, and then the consumer, which is the NFV controller, receives these events. So as part of these 3 events, we take different actions, and I'm going to talk about it. So the first one is the address group. Address group is whenever you have something like from which has this kind of stuff. So what Antrea controller does is it creates an address group, and then this address group for NFV will either contain an IP set or external entity. So whenever NFV receives this, NFV controller receives this, it computes the members, which is from external entity to which VM in public cloud this address group belongs to. And for this particular address group, we create a network security group in cloud. And then once we have created this network security group, we attach that network security group to all the VMs or all the external entities which are part of this address group. So we do this because if you have an address group, you can use that as one of the ingress field, one of the field in the actual cloud group. You don't have to convert the address group members and figure out their IP set and then apply them in the cloud as different IPs. You can also create like another address security group or a network security group in cloud and use as from this particular network security group to this particular port allow, something like that. So that's the significance of address group event. Applied to event is similar to the address group event, wherein once we receive it, we again compute the members like from external entity to the VM. We also create a network security group for this applied to group. And then we also attach that particular, this newly created NSG to the virtual machines, typically at the NIC level. Lastly, the NP event. In NP event, we compute the rules like ingress and egress rules. And then these rules are actually applied under this applied to NSGs. We don't create another NSGs for this rules. This is actually applied on the applied to network security group. So think of it in this way that the address group is just used as a placeholder which is used as a reference in the applied to security group, and then the rules are actually added as a cloud rules inside the applied to network security. Okay. Moving on, what we have also included in this project is we also have Terraform scripts for deploying an AKS and EKS cluster. And we also added Terraform scripts wherein you can quickly create a VPC or a VNet, and it will have a 3 VM with Apache installed. So these are the things we have included in the NEFI project. Future scope, agented support. So as you can guess that this Antrea network policy enforcement is happening agentlessly using cloud construct. In future, in the next release, we also want to add agented support in which we will run a VM agent on the public cloud VMs, and enforcement would happen via OVS. We want to add more match criteria like tags. Today, we just support VPC ID, VPC name, VM ID, and VM name. We would also like to group resources based on tags too, or add resources based on tags. Right now, the support is only for virtual machine, but we would like to extend this for other services, native services, RDS instances, and so on. See, at the end of the day, any public cloud resource wherein we can add a security group, so that can be imported as external entity in Kubernetes cluster. So that is the idea. So if a resource has network security group, so and we can create an external entity for it, then we should be able to protect that and apply Antrea network policy on it. More public clouds like GCP, and then we will also evaluate if we have to serve, how do we do support deny action, as Jinjun mentioned. Demo time. Any questions before I jump to the demo?
Just a question on the structure of the Antrea network policies. Clearly, if the applied group is not of kind NEFI, specifying a kind NEFI as from close simply makes no sense, right? Because as you said, the NEFI enforcement makes sense only when applied to as an external entity.
Correct.
So okay, perfect. So it's not like there's a scenario where I can have applied to pods with an external entity being a virtual machine. It only makes sense when applied to as an external entity.
Applied to is an external entity, and this external entity is created by NEFI. So
Okay.
when I the external entity information in the demo, then it will be clear that we add this special tag in the external entity, and using that hint, Antrea controller disperses the policy to NEFI controller. Otherwise, it will be blocked at the Antrea controller itself.
Okay. Thanks for the clarification.
All right.
Okay. Are
So
we ready for the demo, or is there any final question regarding the design and the specification of external entities? Let's just wait 5 more seconds. Silence. Well, I guess we can get, we are ready for the demo. Please go ahead.
yeah, in the interest of time. So I have already created a kind cluster in which I'm already running Antrea a 1.8 version. Now I'm gonna add NEFI in it. Oh, sorry. So as you can see, the NEFI controller is running. So we just create one replica of NEFI controller. Now, as the next step would be to add a cloud provider account. So the cloud provider account, for that we have to create a secret first. So I cannot show you the secret because the basic repo encoded on my secret. So I'll just apply that YAML. So it does create a demo namespace and a secret, but just to show you, I have another YAML wherein I just have a placeholder. By the way, who is in charge of the recording? Because my secret was in open. So can someone just cancel the last?
No worries, no worries. We'll publish the secret on all websites.
Okay.
Yeah, but just yes, we'll edit it.
Yeah, just trim that part of it.
Sounds
Okay.
good.
So yeah, so this is secret. And then we'll apply a CPA object. So the CPA object basically has a reference to the secret which I just created. So we'll apply that. Then the next step is the CES object. So I'll show you the CES object too. So in the CES object, it is pointing to the AWS account which we just added. And I'm using a VM selector, and the VM selector has this VPC ID. So any virtual machines, I'll show you the virtual machines on cloud too now. So on this particular VPC, which is this VPC 21, you see there are 3 VMs in public cloud. So this demo is for AWS cloud. So you see these 3 VMs would be automatically imported in our Kubernetes cluster. So let's apply this. Okay. So now what Nephi would do is going to poll AWS cloud, and it'll add the virtual machine. So as you see that this is mostly for visibility, that from which VPC this VM which has instance ID is imported, its running state and so on. And we also carry tags. So I'll just show you the tags too. First, let me just show the owner references. So this, remember in the slide, I just mentioned that we had dependencies. So this object owner is actually the CES object, and this is the ID of CES object and so on. Here, whatever, so these are some of the default tags which we add, like what is the instance ID of this virtual machine, what is the VPC ID, and if I add any tag on that particular virtual machine, those would be imported here too. So you can create an entity selector, or basically you can create a ANP with an external entity selector matching any of the tags which you add in cloud too. So that is the idea of it.
But Rahul, this is annotation. Why it isn't the label? I think you can only.
Yeah, I meant on the external entity you will be doing that.
Oh, okay.
Okay. So if you see, these are those are the annotations we add, and based on the annotations we add these labels on the external entity. So if you see here, this is the name, which is a tag in AWS. The kind is like some fixed tags which we add. Environment is this is a kind of tag. What VPC this external entity belongs to. So all these things, I mean, like user can apply an ANP with match selector as any of the labels. And these labels are actually, let me show you what these labels are. These labels are actually tags here on the public cloud resource. Typically what people do is they add tags to the resources, and they use these tags as groups for grouping purpose. So what we do is we also read this tag from the public cloud resource and add them as labels on the external entity. And the other thing which I was talking about is, as this external entity is created by Nephi controller, we set this field in the external entity as Nephi controller. So any Antrea network policy matching an external entity which is created with this particular tag, then only the NEFI controller will receive the network policy. I hope it makes sense now. Okay. So as you can see, the virtual machine CR is created, external entity CR is created, and the next thing is to apply a entry network policy and see that in action. So in this entry network policy, I'm adding two entry network policy. One will include an IP block, which will basically allow SSH from anywhere. And then the second one is because I'm adding this another from external entity selector to show you that for even for the address, this will translate to an address group event. So even for address group event, we do create a network security group in cloud, and I'm going to show that is the reason I'm showing adding external entity selector in the from field too. So we'll see both the IP set in action or IP block in action, and we'll also see the address group in action on the cloud side and how things translates to. And again, this is applied on the match label with kind.nefi as virtual machine. We could use the VM ID also and so on, but I just wanted to keep it simple. So now I have 3 VMs, so these policies would be applied on all 3 VMs. So let's apply this. Okay. So both the policies are created. So now let's go to the cloud. So as you can see, this instance has 2 security group, which has prefix as NEFI. AG means this is an address group. AT means is an applied to group. This is the ID. This is the ID of the internal ID of the group. And if you see here, one was IP block. So we had an IP block. And then the second one is an address group. So we created another address group here. And then this address group is actually used as a source field. So any VM which has this particular address group attached to it, so this policy will take into effect. So that is the idea of it. So I can have an address group with more than 1 VMs in it. What I'll do in cloud is I create a security group for it, attach that security group to the VM, and use the security group ID as in the rule field, in the source field, basically. I'll take a pause here. Just before that, I'll also cover this. So we also added internal CR for it, which is served via an aggregated API server, not via Kubernetes. So it actually shows the realization status, how many policies are applied, and if there are any errors. Like so what are the policies which are applied on a particular VM? So this is the cloud resource, which is virtual machine. Now let's take this the last one, the cloud resource. And then it has 2 network policies applied, which is SSH, allow SSH, and allow within VPC. And it shows the realization status of each virtual machine, like realization status of the entry network policy. So the brief overview is going to show you how many network policies are applied, the overall realization status. And if there are any errors here, you can look at the description field, and in the description field, it will carry the reason why this particular network policy was not applied. This is not served by ETC, it is internal and it's served by aggregated API server. All right, I think time for Q&A. You guys have any questions?
Thanks for the presentation, Raul. So yeah, let's open up for questions. Let's give a few minutes to team members to think about this presentation and come up with some questions.
Rahul, I have small comments about the virtual machines annotation. I think that they are copied from the tags of the virtual machines, right? I feel if we use label instead of annotations, it would be more friendly, as we could also list selected virtual machines by using the tag, right? But if you use annotations, it can only be used for visibility, cannot be used as selector. For example, if I want to list.
Yes, that's right, Chen. Yeah, that's right. Actually, our plan is to deprecate this and serve it using aggregated API server, not like a first class citizen as a served by backed by etcd. So that is there. This is a temporary thing. Probably in next release, we plan to remove it. So at that time, we will probably consider to change it.
Okay, thank you.
Yeah. Because what we wanted to this kind of visibility at the end of the day. So what we decided is we separated it out into a different object. And this is what we are showing at per VM level. What is the realization status of each network policy? So given that we have this, we can completely get away from the virtual machine CRD too.
Okay, got it.
Thanks. Apart from this, the project is here. It's open source. Everyone can take a look at it. We do have good documentation, which covers the architecture, what are the subcomponents inside NFV controller, how things work. So you can take a look at this too. And we do have documentation on the network policy, which I just covered, that how things work, how it gets applied on the cloud side. So this is little detailed. You guys can take a look at this too. Yeah.
Yeah, thanks, Rahul. That's a lot of information. Yeah, thanks for all the pointers. All right, we are already 15 minutes over time. So do we have any final question for Rahul and the NEFI team? Waiting 10 more seconds.